welcome to lecture number 40, and as you know we have been discussing about circuit analysis when mutually coupled coils will be also present apart from normal RL etc. So, we are concentrating upon mutually coupled coils, and let us do just quickly write down so that you can review the other things. For example, I say there are 3 coils, very quickly I will do, so that you also this time I will do rather easily without drawing those circles, this that. It is like, suppose there are 3 coils here, there is some AC voltage connected V t plus minus. Once you are very much accustomed to it, you can write down without going that detail. What I am telling is, suppose this is L 1 and this is L 2, this is L 3, and this coils will have mutual inductance between these two, L 1 L 2 is suppose M 1 2, got the point. And this coil, say I will take for this one, the dot of this coil is shown to be here, and this is M 1 3. Similarly, these two will have a mutual inductance of M 2 3. So, all the 3 coils are coupled here. Now, how to write down the KVL here? So, to do this, and suppose I say this current is I 1 and this current is suppose I 2. This is my prerogative to choose the direction of the current, as I have been telling many a times. So, I 2, I 3 and I 1 are the currents in the coils, and I have to write down the voltage equation, KVL equations. How many meshes are there? 2 meshes, 1 and 2. Okay. So, the KVL equation in this mesh I want to write down, got the point, this mesh, which I will try to do it in one way. So, this is I 1. See, the voltage drop between these 2 points will be L 1 d I 1 dt, definitely, because I 1 is entering, this will be plus. But there will be another 2 EMF, one because of I 2, they have mutual coupling. So, that term will be M d I 2 dt, and between these 2 points there will be another term which is M 1 3, M this was M 1 2, this is M 1 3 d I 3 dt. This will be the thing, these will be the drops here. Now, the question is L 1 the drop across A B, these terminals L 1 d I 1 dt, fine, this will be plus. What about the other terms, plus minus or minus plus? How do I decide? You see, I 2 is flowing like this, through the dot it is entering, therefore, mutual induced voltage in L 1 will be left side dot, so plus. For this coil, it is leaving dot, therefore, right hand side will become plus, that is so this will be minus. I am now avoiding all those small steps. You should be your understanding should be at this level now, quickly you should write it, or you think in this way that for these two coils, these two are dots, then these two are also dots. At best you can do this, which square square I am writing. So, through this square it is entering. So, this square will become plus like that. So, it will be right hand side and this must be equal to your V t, that is all. This is in the first loop, this equation. In this loop, this equation will be, you start from anywhere, for example, here in this loop, it will be L2 di2 dt L1 di1 dt I have taken, M12 di2 dt I have taken, then M13 di3 dt. This is across L1, sorry, thank you, you are right. So, this only is across L1, thank you. So, this is only across L1. Then I have to write down the voltage drop between these 2 points to get V t. So, what will be those terms? So, this will be plus L2 di2 dt, fine. Then because of 1 there will be induced voltage. So, plus which side will be plus? This left hand side, because through dot I1 is entering dot. So, M12 di1 dt, this will be this one, and for this if these two are dots, these two are also dot, square. So, through square I3 is entering I3, this square will become plus. So, it will be minus M23 d I3 dt, and this will be equal to your V t. Now, it is correct. So, this. Similarly, in this loop, if you go by, you will see that L2 di2 dt, and for this one, this will be plus this side plus. So, this will be M12 di1 dt. Then you reach this point, then from this to this you are coming. So, it will be minus L3 di3 dt in this loop I am writing. So, this is okay, na? So, L2 di2 dt plus 2 minus, then once again plus 2 minus M1 to L1 di1 dt, because left hand side is plus. For this fellow, it is you can write it best way is to there are so many ways you form your own mechanism. Okay, this always I will write plus. Interesting. I mean d dt of this side plus this side minus is, then you write minus I3, I3 is entering, minus I3 is entering. So, this side plus this side minus L2 this is L2 di2 dt plus M12, then M3 is there. This, then M23, because of that also there will be voltage. So, 3 sources, self, and for 2 mutual, this to this and this to this. So, what should be the polarity of this voltage? I2 is entering here, this must be minus, this must be minus, because the right hand side is plus, through the dot the square. So, this side will be plus. So, minus M23 di3 dt. This then 3 terms here I have reached from this to this point. Then from this to this point, it will be minus L 3 d I 3 dt. Then another 2 terms, this and because of this. Because of this, this is dot. So, this left hand side is plus. So, this will be also minus m 1 3 d I 1 dt, and through the dot it was entering. So, this will be plus m 2 3 d I 2 dt, and that must be equal to 0. That is what I am telling. So, this is the thing, correct. Now, what I am telling, if somebody says that this is dot, current is entering like this, you devise your own method, and if any problem, then go to the basics, but you have your own ways of correctly writing that. You can always imagine that current is entering through dot. For example, here the dot terminals were mentioned. What I am trying to tell? Here the dot terminal is mentioned, but I 3 direction is leaving the dot. You imagine minus I 3 is entering, that is the variable m, this one m 1 3 d I 1 dt, m 1 3 d I 1 dt, it will be plus. Or another way of writing it, what I am telling, you always pretend that current is entering through dot, then no confusion. For example, in this one current is entering through dot is I 2. So, L 2 in this loop I am writing. So, L 2 d I 2 dt, this side plus this side minus. Through this dot current is entering I 1. So, plus m 1 2 d I 1 dt. Now, here once again I will write plus because of this coil, and I will write m 2 3, left hand side will be only plus, but then you have to write d dt, what is entering through dot, minus I 3. That will bring that minus sign here. Got the point? Similarly, come here. Here you imagine through the dot currents are entering. So, plus L 3 d dt of minus I 3, you write it. So, right hand side will be. So, through the dot. So, plus m 1 3 d I 1 dt, fine, d I 1 dt, and through this dot it has come. So, plus m 1 3 d I 1 dt, dot entering dot here, and finally, this 2 through the dot entering. So, right hand side will be there m 2 3 d I 2 dt. This negative sign is this negative sign. Anyway, we will be able to write down the KVL equation correctly, provided I know the dot conventions. Achha, now I will tell you about the energy expression, energy stored in mutually coupled coils. Only 2 coils I will consider, we can find out for many more coils. So, that is what I want to find out. That is what I want to say. Suppose there are two coils, one inductance is there L1, it carries a current I1 at any instant. How much is the energy stored? We have seen half L I1 square. Now, suppose there are two coils are there which are mutually coupled, and one is carrying a current I1, another is carrying a current I2. How much is the energy stored? We want to know. This is L1, this is L2, these are given, and this is mutual inductance between them. This is the problem. What is W? Suppose at a given instant they are carrying current I1 and I2. Now, this is in an interesting way we can do it. Suppose these are the two coils, okay? And suppose here I have connected a voltage source V1t, and let us assume these inductances are having no resistance. So, this is V1t, and here also I have connected a voltage source V2t. And the direction of the current I will assume, suppose these two are dots given, without dot you can't proceed. So, I1t and this current on the other coil, let it be assumed to be directed in this direction. This is the thing. Okay. So, this is L1, this is L2, and this is the mutual inductance between them, and this circuit is equivalent to V1t is there, and across which two sources are connected plus minus, which is L1 di1 dt, and there is another source. Through the dot current is entering, this dot will become plus. So, plus minus M di2 dt, is not? This will be the primary side thing. Mutual inductance between them is M. Similarly, in the second coil, the voltage applied is V2t with this polarity V2t, and you have two sources of EMF in series. One is obviously I2 is entering. So, L2 di2 dt with this plus this minus. Why? Because I2 is assumed like that, mind you, this is I1. And through the dot I1 is entering, this dot will become plus. So, upper one is plus, plus minus M di1 dt. And let the things be time varying. I am not at all worried whether on both the side sources are connected or not. So, I have drawn the KVL, I mean the voltage, instantaneous voltage polarity is hopefully correctly like this. Acha. At any time t, these are the two terminals of the coil A, B, and this is suppose C, D, this is A, B. Now, supply voltage has got a polarity like this, and V A B across which this mutual coils comes in. Therefore, this block, this one is absorbing power, instantaneous power absorbed by absorbed by AB, this element AB element will be V 1 into I 1 instantaneous power. And instantaneous power in the same way absorbed by coil C D will be, you see the voltage between these 2 points plus minus and current is I 2. So, it is absorbing power. So, this will be equal to V 2, if you please allow me to write in this way. Instantaneous power absorbed by AB will be the voltage V A B, which happens to be equal to V 1 T. I can write that, but I know now in terms of L 1 L 2 I have to find out. So, this will be L 1 d I 1 dt, voltage between these 2 points A B, plus M d I 2 dt. Similarly, same thing which I am not writing in language, power absorbed by C D, instantaneous power, will be this voltage, that is L 2 d I 2 dt plus M d I 1 dt. Here it must be multiplied by I 1 and here it must be multiplied by voltage into instantaneous current. This will be the thing. Therefore, to this system ABCD, to the coupled coil, to this coupled coils, instantaneous power absorbed, will be equal to sum of these two, is not. So, L 1 d I 1 dt plus M d I 2 t d I 2 dt into I 1 plus of L 2 d I 2 dt plus M d I 1 dt into I 2. This will be the instantaneous power, total power, that is P A B P T, let me write. P T will be like this. Which is equal to P A B plus P C T equal to this. This I can write. Okay. Therefore, energy supplied to the system in time dt will be, therefore, energy elemental energy supplied to the coupled coil, supplied total elemental energy supplied to the coupled coils will be equal to dW is equal to PT into dt, is not. Redraw the circuit here for ready reference. So, this was L 1, this was L 2, this is V 1 minus this is V 2, and I have assumed current to be flowing like this, and this is I 1. So, P t into d t is the total energy supplied. So, it was equal to, we have seen, L 1 d I 1 d t plus m d I 2 d t into d t plus L 2 d I 2 d t plus m, and mind you, I have assumed the dots like this, m d I 1 d t, and this is also multiplied by d t. This will be the thing, which can be written as L 1 open the brackets d t into d t, this d t push it inside, plus m d I 2 plus L 2 d I 2 d t into d t plus m d I 1, isn't it? Into dt cancels out here. Similarly, dt cancels out here. So, this will be the thing. So, this one then becomes L 1 d I 1. Another important thing I missed, what is that? That is voltage into current, is not? Hopefully I wrote it here in the previous section. Into I 1 into I 2. So, this was into I 1, mind you, and this was into I 2, that is there. So, this I 1 will come I 1 here, and also here I 1 will come, and also here I 2 will come, and I 2 will come, isn't it? This will be the thing. Now, this d t goes, cancel them out. So, it will be L 1 I 1 d I 1 plus L 2 I 2 d I 2, this was 1, I 2 plus m I 1 d I 2 plus m I 2 d I 1. This will be the energy, not energy supplied in time d t, elemental energy. Oh, 2 bars. So, this m I have written twice, correct. So, this will be the thing. Now, you see, if therefore, total energy stored, total energy absorbed by the system, if I 1 and I 2 are brought to the level to the final level I 1 I 2 say capital I 1 and I 2, I 1 and I 2 from 0 values, then energy, total energy absorbed by the system should be L 1, this is I 1 d 1. So, I must write the limit of I 1 0 to I 1, fine. Similarly, plus L 2, I will here only I 2 d 2 I have to integrate, and suppose the current is 0 to I 2, and for this one, these two terms I 1 d I 2 plus I 2 d by 1 can be written as d I 1 I 2, product of differentiation. And then I should write the limit of I 1 I 2, which was 0, and finally is I 1 I 2 product. So, this will give us the familiar terms L 1 I 1 square, first two terms are very familiar, plus half L 2 I 2 square, then plus m I 1 into I 2. In other words, after getting this, I will tell if at any instant of time I know the value of I 1, I 2, that may be time varying at any instant of time, okay, this current, then energy stored in the inductor is half L 1 I 1 square, second inductor will store energy half L 2 I 2 square, and then the energy stored because of that mutual coupling is m I 1 I 2, all these three will go. In general, I should say the energy stored should be at any instant, if the current in the first coil is small I 1 plus half L 2 I 2 square is the current in the second, then m I 1 I 2 will be the total energy stored in a coupled coils. Got the point? Because after all these are coils, lines of forces will be there, and this therefore will be the energy stored. In a single inductor L, half L I 1 I, we did the same thing, voltage across the inductance, current flowing into it, and then L 1 d I 1 dt, in time dt, how much energy you are supplying, then you are integrating from 0 to I 1. Similarly, second term, and fortunately these two terms comes in such a beautiful fashion that I 1 d I 2 into I 2 d I 1 is nothing but this term is nothing but m d of I 1 I 2, differential, perfect differential, product of two variables. So, I 1 d I 2, I 2 d I 1 is m d I 1, and then you assume okay, at this instant current is capital I 1 I 2, and everything started from 0, this change in. So, limit of this one should be product of these two, because the integral of this one will be I 1 I 2. So, 0 to I 1 I 2. So, always remember that in mutually coupled coils, the energy stored will be half L 1 I 1 square plus half L 2 I 2 square plus m into I 1 into I 2. Thank you.